Hi everyone, I'm Alex. I lead the AppSec and research group in Checkmarks. I'm part of a product that is called SCA, Software Composition Analysis. And what we basically do is scan source codes of customers and specifically the dependencies of their code to find vulnerabilities, license issues, offer remediation, and things like that. We work mainly in the space of open source code and static analysis of the code. And yeah, that's where I'm coming from. Today I'm going to talk about certain research and workshops we've made on how to systematically find 0 days in open source packages. And let me start by maybe talking about why we did it in the first place. Okay, so let's talk about where this initiative started in the first place. So you can think of SCA, our product, the software composition analysis tool, as a tool that is given a source code, and from that it detects the dependencies inside this code. So if we're talking, for example, about Python, you can think about the requirements.txt file. If it's NPM, you can think about the NPM lock or JSON files. And we take those manifest files, we find the dependencies, and then we can show the customer all the vulnerabilities that he has, the license issues that go along with it, if it's, for example, using a package with a problematic license. And we obviously offer remediation actions and many advanced features in addition to that. But in the basic, looking at it from a basic perspective, our product is it has a giant database of vulnerabilities, and the more vulnerabilities we have in it, the better value we provide for our customers. So of course, there are all the CVEs that are published in NVD or globally in various open source packages, but obviously those are not all the vulnerabilities that are out there. And the more vulnerabilities that we have in our database, the better. So we wanted to increase the number of vulnerabilities there. In addition, we have one of the teams in my group is an analyst, is a team of application security analysts. And we wanted to offer them training and improve their 0-day research skills. And we thought that by doing a hands-on workshop or multiple workshops, they will also get more, they will become better researchers themselves. So it's a win-win situation for us. We can search for vulnerabilities on the one hand, we improve our skills on the other hand. But the question is, how do you even start to train someone to research for 0 days? So we decided to focus on web exploits and ultimately NPM packages. And let me show you how it was done. So originally we wanted to find 0 days, and we started with the WordPress workshop. And by workshop, I mean that it's a few days that are dedicated to 0-day research, that the team is focusing solely on that. It gives them a good pause in the sense of their regular work, and it really focuses them on the craft of researching 0 days, because the fact is that research takes time. You don't want it to be interrupted. And so we did it in the format of workshops. And obviously they have their day-to-day work, which is important to me. So we had to do it in this format. We started with the WordPress workshop, and then we went to more NPM focused ones. So we did 2 NPM workshops. I will go through everything that we did in future slides. But the main idea of the talk is that I'm going to walk you through the process that we had in our team and how it all came together. So I talked about open source packages on the one hand, and now I'm talking about WordPress. So why is that? So WordPress as a general is a great playground for researching vulnerabilities because it's very UI based. And since we're focused, our ultimate focus was NPM, which is language and JavaScript, which are systems for developing websites. The idea was to start the research with a playground that is easier for the starting researcher. Starting by like going straight up to source code of packages, it might be hard. It might be hard to understand how you can exploit certain vulnerabilities, what's the impact there. So we wanted to start with something much more simple and basic. And the WordPress is a great environment in that sense that if you find a cross-site scripting vulnerability there, an XSS, it's pretty much equal to a remote code execution, right? Because if you have an XSS, you can run JavaScript, and this pretty much gives you the option to remote code execution. In addition, WordPress is very popular, and it's about a third of the internet traffic. And there are many plugins there that are and the plugins of WordPress are open source. So in this sense, it's similar to the notion that we were trying to accomplish of researching 0 days in open source code. So we did this by first introducing our team to Docker, and we obviously all the research was done in a responsibly in dedicated environments. Like we didn't want, of course, for the researchers or the analysts to run WordPress directly on their computer, start installing various plugins and starting to research different vulnerabilities there and attack vectors. So we first had to introduce the team to working with Docker. By working with Docker, you work in a sandboxed environment that has, and everything you do has no implications on your computer. So this was like a general first step into how you research vulnerabilities in the first place. And when you start to download various sources and codes and binaries from the internet, you should work in a sterilized environment. So that was very important to us. And we actually did some pre-work on various WordPress plugins, and we found plugins that were likely to be vulnerable to various attacks, if it's cross-site request forgery, or CSRF, or XSS, and etc. The idea here was that we wanted to, in a sense, help our researchers, because like how do you find vulnerabilities when you're just given the entire WordPress when you're just giving WordPress and you're not giving any direction to which packages or which plugins you should start with or not. So with the WordPress, it was more built as indeed as a starting point. We offered the list of plugins that are likely to be vulnerable. I won't go into detail on what it means because it's a bit out of scope, but believe me that it was productive. And let's talk about let's jump into the results, because I want to focus more on NPM. So the results of the workshop were pretty impressive. We found 8 vulnerabilities in a matter of about 24 hours. It was done by a team of about 8 researchers. So pretty much it's about a 1-to-1 ratio. And those vulnerabilities were affecting about almost 500,000 active websites on the web, which is interesting because it's quite a large number of affected websites. Of course, we disclosed all the vulnerabilities. We contacted the maintainers. They issued patches for it. So of course, we are doing everything. We're trying to make obviously the internet safer and not just less safe. So so by doing this workshop, we realized that by only 24 hours we were able to accomplish a lot of vulnerabilities that were found, and those workshops had a lot of value. And after that, we felt more comfortable with going to the NPM, which is our main challenge. So let's talk about NPM. So NPM is a package manager for JavaScript. You can look at it at npmjs.com. There are many various packages in NPM. Currently, there are about 1.3 million. And on the other hand, if you look at the different vulnerability types that are currently existing, and this is a statistic I took from NVD, there are more than 600 different vulnerability types and attack vectors. And the question is, like, how do you find vulnerabilities in all that? Like, on the one hand, you want to look for something maybe specific, but on the other hand, you have so many packages. So where do you start? And the idea was to have some sort of a tunnel vision on how we want to research those, how we want to find the vulnerabilities. So the idea was that instead of looking at like the all packages and all attack vectors, we needed to start with something very specific. So the first step we had to do is to choose an attack vector. A very popular and easy to research and exploit one is command injection. So once we have the attack vector, the second step is to understand which methods enable this attack vector in the code, right? We want to, in the end, we're looking at source code of those packages. So how do we know if this attack vector is feasible or exploitable in that context? So, for example, we researched various functions that enable this, that can enable this attack vector. For example, exec is a function that runs a command that is given to inside a shell. So imagine that a certain parameter is passed to this exec function. It runs inside a shell. If you are able to if you're able to alter this the value of this parameter, you can basically inject anything that will run inside the shell, and you get a remote code execution or just a command through a command injection. So once we know what method we want for the attack vector, we need to think of what NPM packages are likely to have this attack vector in the first place. Because if we want to search for command injections, we can look at dozens of packages, and none of them will even have an exec function, or none of them will have a command injection. So from the other side, we need to focus on which packages in NPM we want to research. We don't want to research all of them because it's just too much. So we wanted to focus on NPM packages. So for example, one sort of NPM packages that are likely, if we continue our command injection example, one type of packages that are likely to have this attack vector of command injections are packages that are binary wrapping packages mainly. So for example, packages that are wrapping Git or packing, other binaries. It can be SVN, it can be various other binary. There are plenty of binaries that certain NPM packages run. So yeah, and finally, once we have all that, we need to figure out what is the search keyword that we want to search by in NPM. Because as I said, there are so many packages, we need to know where to start. So in the context of binary wrapping packages, we can think of the keyword Git. And then we can get all the packages that are that match the keyword Git in a certain way, and maybe they have somewhere in their code a running of the Git command inside an exec function or inside the shell or something like that, and that could be exploited. So those steps were made for us to have a certain tunnel vision on how which vulnerabilities we want to find and how to do them. And you can see that it has two steps. One of them is defining the breadcrumbs, I would call it. If it's the breadcrumbs of how to search for an attack, for example, with the specific functions. And the other type of breadcrumbs is for this npm search itself and the prioritization of the npm packages. Okay, so let's talk about the first npm workshop that we did. So we wanted to continue the WordPress research that we did earlier. The npm is a very popular package manager, also, of course, among our customers, but globally as well. Many people write with the npm JavaScript code that runs in web clients, in the front end, in the back end. It's probably one of the in the top 3 most popular languages, depending on how you calculate it, but it's very popular. And it continues the notion of the scope of like attacks in the web that are more web focused, as opposed to, for example, Python or NuGet and C# that in those contexts it's a bit different and they're written in a different code. And here, so you have JavaScript, which is also appears a lot in WordPress, of course, and in their plugins. So it made a lot of sense to continue with npm. So how we did it? So first, we as I said earlier, we needed to define the breadcrumbs. One sort of breadcrumbs is the search keywords. Like, what do we want what are the functions that we want to search in the source code? You can see on the right, for example, how it looked in our code. Those were basically regexes with different functions. And you can see that we search for spawn or spawn sync and exec or even shell equals to try to find functions that could potentially be command injections. And those are the exploitable methods that eventually we will use. The other thing that we needed for this workshop is a tool for the npm search. You can see on the right a screenshot I took from the npm search tool that we have. It's a very simple tool. You give it a search keyword for, if we talked about our example earlier, so it could be Git, and then it queries npm. It starts downloading packages from the basically with the same prioritization that npm gives it to you from the API, and it runs those regexes that we defined earlier, the indicators on the source code, and tries to detect them. So you can see in the right, I'll use my mouse for a second. You can see here, for example, a potential command injection in one package. Here you can see another command injection. Here, this was an exec function running. This was a spawn one. And it provides you the basic indicators of you might want to look into this package, into that line. For example, we can see that this package is not interesting in this context. We didn't find any indicators. And the last step in the researching those packages is what I call a package source code visualizer. When you research many packages through npm in different versions, it's hard that you have to every time to download it and then open it on, I don't know, Visual Studio Code or something. And it's much more, so we developed ourselves like a very simple source code visualizer that you give it as an input, the name of the package. It downloads it in the background and just opens you the entire source code and with a search option. And this way, it's very simple to view the source code of the package. You have a package that you find interesting, you go to this website, you put the name of the package, and you just get the source code instead of doing the process of downloading and opening Visual Studio Code and then closing it and doing it again. When you do this for dozens of packages a day, it becomes really a matter of time, of improper time management, I would say. So those were the basic tools and the basic process we wanted to incorporate in this NPM workshop. And as I said earlier, we had about 8 security analysts. So we gave them 4 days, through those days, we of course helped them with various questions and the indicators, and we actually started adding indicators throughout the workshop, and eventually we got those results. So let's talk about the results of our first NPM workshop. We were actually quite surprised with the amount of vulnerabilities that we were able to find in such a short time. In the matter of 4 days, four research analysts from our team were able to find 33 vulnerabilities that were affecting over 3 million monthly package downloads. So you can think about it that every time one of those packages is downloaded, it's used in a certain product or in a certain source code of a certain developer with those potential vulnerabilities. On the right, you can see the distribution of the different vulnerability types that we had in this workshop. As you can see, most of the vulnerabilities were command injection ones, 94% of them. And that makes sense because in the first workshop, our main indicators were the command injection ones. And as a result, in the future NPM workshops, we understood that we want to maybe expand to various other vulnerability types as well. But as a whole, this was we were very surprised and happy with those results because usually, so people, I don't know if people in the audience are security researchers by day or night, but usually vulnerability research is a process that takes time, takes weeks, even months, and as in the end you find one vulnerability that has maybe impact on one specific product. But here, when we talk about the open source community space, and we as a Checkmarks, we focus a lot in this space, and we want to make the internet safer. We understood that there is a lot of value in finding those vulnerabilities that affect so many monthly package downloads. So let's continue now to one example of such a command injection to show you how those vulnerabilities looked like. So let's take a look at a certain example. Here we have a Samba client package with an assigned CV already, so I can talk about it here. Obviously, vulnerabilities that were not fully disclosed yet or that are still in the disclosure process, I can't mention their specifics, but this one I can. Yeah, as you can see, this vulnerability was also fixed, which is important. We're trying to make the open source community a safer place. Like that's one of our roles as a vendor in the open source scanning space, I would say. And you can see from the code that there is a certain command that is built here, which gets certain parameters from the client, and it later runs inside an exec functions. So it's interesting because those command injection vulnerabilities are actually very popular in older packages. Like the older the package is, it's easier to find a command injection because probably developers also were less security aware at that time. So you can see that so once you know to search for a command injection, it just jumps into your eye, because here you can see an execution of a certain command, and you know that exec runs in a shell. So if you can add a certain parameter to this command, it will run in the shell, and it's basically remote code execution. You can download binaries, you can install malware, you can do everything once you can run in a shell, and the parameters that are passed to the shell are received from the user input without any sanitization. And that's the issue here. If the command was sanitized, if the parameters there were sanitized, then this command injection wouldn't work. But the problem here is that it doesn't happen. And think of the developer that is using the Samba client package. The developer doesn't even think that the command that he passes through to the package might be used might actually be a command injection. So he's using a certain package and he expects it to work in a certain way in the happy flow. But when it's an attacker, it's not necessarily the happy flow that is in focus here. So so as you can see, it's quite a simple vulnerability, and we found many others like that. And it all came down to being able to pass an argument that is user controlled into these exact functions. So now that we talked about the first workshop that we did, let's talk about how we wanted to improve for our next workshop. So the main thing that we did was to improve our list of indicators. So in the first workshop, we focused more on command injection, and you could see it in the results. And we wanted to pivot to other attack vectors as well. So we started looking at directory traversal vulnerabilities, SQL injections, deserialization, prototype pollution, and things like that. And then we, again, started running it on various NPM projects. You can see it on the right, and started getting this list of indicators. And the results were quite surprising in the second workshop. So in the second workshop that took about 3 days, we found 12 vulnerabilities, this time with a lower number than the 33 earlier. But those vulnerabilities are much more, are affecting much more monthly downloads of packages. And I think the reason here is that we were able to find vulnerabilities in more popular packages, and we started looking at other various attack vectors that were probably also less researched by the community, because command injection is probably the most basic vulnerability type. So it makes sense that most of them will be solved, especially for popular packages. But as you drill down into different attack vectors, you start seeing different, it becomes easier, I would say, if you're focused on this specific attack vector, to find it in popular packages. And we were able to find various attack vectors. You can see the distribution on the right. This time, command injections were only about 42% of all the vulnerabilities. We found this deserialization RCE, prototype pollution, hostname spoofing, and generally we were very happy with the results of this workshop. We were able to find not just one attack vulnerability, not just from one attack vector, but from various ones. And that's that was pretty much what we aimed for and what we were hoping to accomplish. And I think that what I can draw from this slide, or from this experience that we had, is that focusing on those hard vulnerabilities that require a lot of research in a very certain package or a very certain product, when you look at the open source community, it might not be the most cost-effective way of making this space safer. Focusing on easier to find vulnerabilities that affect a lot of package downloads each month is maybe more valuable when you look at the grand scheme of things. So after we got the results of the second NPM workshop, we were very pleased, and we of course had a lot of ideas on things we could do next. And I want to briefly talk about the various ideas and that we have for the future workshops. So one thing is that we noticed during those workshops is that we were using regexes to find those indicators, those spawn functions or exec functions, and regex, while they're a very simple tool to find text inside the text, it had a lot of false positives. For example, when you look at the spawn function in npm, actually this function is prone for command injection only in the case that it has an additional parameter of shell equals true. The reason for that is that spawn by default doesn't run inside the shell, and the parameter that it gets to run is it expects to get a file path or a binary file path. And if it has a command injection, for example, it will just not find a file with that name and it won't run it, and then you don't have any attack vector here. So the idea was to use more advanced tools to find more and to better find potential vulnerability indicators. One of those potential tools could be SAST. SAST is Static Abstract Syntax Tree. This is what it stands for, and it actually the first product that Checkmarx ever developed. And SAST is a tool that takes your source code, it breaks it into an abstract syntax tree, and gives you the option to run certain queries on it. So a query, for example, could be find me all the spawn functions that also have shell equals true. This way, we minimize the false positives that we have with indicators that are not real indicators. The other thing that we encountered is that many times we would find an indicator, but it wasn't exploitable, in the sense that for a command injection, for example, to be exploitable, you need a certain user controlled param to reach this exec or spawn function. If there isn't a parameter that you as an attacker control, you can't exploit anything. And we had to check it every time. Every time we saw such an indicator, we had to check, is it user controllable, and can I pass this argument to the function? SAST, for example, Checkmarx's SAST tool actually offers a DFG option, which is the data flow graph, and it allows us to ask the question, is there a user input that reaches this certain function? So, for example, is there a user I don't know, parameter that gets to this spawn function? And only in case that it does, then we can say that this is an indicator for a potential vulnerability. And the idea behind this, using SAST and using DFG and all those ideas, is to minimize the amount of false positives that we have. One issue that was very apparent in the workshops is that analysts were facing a lot of false positives, a lot of potential vulnerabilities or command injections that ended up not being exploitable for those various reasons. And obviously, the more we minimize the number of false positives that we have, the more the more packages we get to cover, and the more potential vulnerabilities we are able to find. So those are like the various ideas that we have for the future. I hope we will implement them and we'll find more 0 days systematically. We can, of course, expand those ideas to various other various programming languages as well. Command injection is a vulnerability that can be in pretty much every language, of course. It doesn't have to be NPM specific. We started everything when I said that we wanted to be more web and more web focused, but it ended up being different. We took a little pivot in this sense. But it's interesting because those conclusions and ideas that we have can be expanded to other programming languages as well. So that pretty much concludes my talk on how to systematically find vulnerabilities in open source packages. I hope you find it insightful and interesting. And I hope you also can, and maybe you can also take some of those ideas and search for vulnerabilities and make the open source community a safer place for developers and customers alike. So thank you for joining this session. I hope you enjoyed it. I hope you enjoy the rest of the conference. And thank you and take care.